Hello. In this video, recall that if x equals k is a zero of a polynomial p of x, then x minus k is a factor of p of x. Therefore, once all the zeros of a polynomial function are known, the polynomial function can be completely factored. So using your graphing calculator and synthetic division to find all zeros of the following polynomial functions, we're going to factor the polynomial completely. So we have f of x equals x cubed minus x squared minus 17x minus 15. Now, in the past, I might have told you to factor this on your own, but even with grouping, this cannot be factored like normal. So what we're going to do is we're going to use synthetic division to find all of the zeros. Now, we could start with guessing and checking different zeros, but the best thing is just use the resources you have. So start with your calculator and see one of the zeros. I'll go ahead and see in the calculator. Okay, so we're back at the calculator. Let's go ahead and type this in, x to the third power minus x squared minus 17x minus 15. And then graph on the standard window, and here it is. Notice that the graph crosses at -3, -1, and what is that, 5? And notice they are linear crossing, so they're all multiplicity 1, and that's good because the degree is 3. So there you go. So the zeros are -3, -1, and 5. Now that we know that, we can go back to the notes and start factoring this completely. I'll see you there. Okay, welcome back to the notes here. Just a reminder, we have -3, -1, and 5 as the zeros, so let's go ahead and test the -3. Upside down division, 1, -1, -17, -15. Bring down the 1, multiply, add, multiply, add, multiply, and add. And we just proved that -3 is a 0, and we do have what we see here is we see a quadratic. So if you want to, you could just write down the quadratic and factor that. But let's just continue with the other zeros. The next zero that we saw was -1. So bring the 1 down, multiply, add, multiply, and add. Good. So that -1 is a 0 for sure. And now let's prove the 5. So put the 5, bring down the 1, multiply, and add. Awesome. So there are 3 zeros here. The zeros are -3, -1, and 5. Notice that the 1 down here is just the leading coefficient, just a reminder. I keep saying that so that people don't confuse that with a 0. Okay, so the zeros are the following. They are -3, -1, and 5. Now, notice that each one of these has a multiplicity of 1 because each of these is only used as a 0 one time. So that means that this -3 has a factor of x plus 3. The -1 has a factor of x plus 1, and the 5 has a factor of x minus 5. Now notice if these had multiplicities other than 1, let's say the -3 had a multiplicity of 2, we would make that x plus 3 squared. That's all we would do. Okay, so these are the factors. That means that the function will be the first factor, x plus 3, times the second factor, x plus 1, times the last factor of x minus 5, and then make sure that the leading coefficient is here. Because it's 1, we don't need to write it. And there you go. We just completely factored this degree 3 polynomial. It's a quadrinomial technically. Alrighty. Well, I'll go ahead and leave it here, and I will see you in the next video. Have fun.